In this section, we are going to focus on switch network optimizations. Network optimizations can consist of quite a few things, and what we're going to take a look at from the physical layer and work our way up to the layer 2 functionality optimizations. So for layer 1 optimizations, we're going to take a look at port and media operations and port types. What is the difference between full duplex and half duplex? What is gigabit versus 100 meg? What are some of the counters at the interface level? Some of the port types we're going to take a look at are going to be, are they, is it an edge port? Is it a trunk port? What are the details behind each one? We'll take a look at spanning tree protocol in its a setup, and then what we're going to take a look at after we have spanning tree in place and operational, we're going to take a look at why spanning tree does what it does, and then you'll see once we go through the spanning tree section why having ether channels in place and then the alternative to ether channel flex links comes into place. And that really comes down to the meat and potatoes of why network optimizations are so critical. Because so far what we've got going on is we have VLANs configured, we have trunky configured, and we have VLAN replication configured. So we already proved out that all of the routers can talk to each other as long as they're connected to their directly connected neighbors. Now, in order to optimize the switched environment, we need to take it to the next level. And before we do that, we need to make sure we understand at the port level how that comes into play. So we're going to do that by taking a look at the port settings. Now, we have half duplex communication, which is going to be the sender can send but can't receive at the same time. You have full duplex communication, which means the sender can both send and receive at the same time, which effectively will give you, if you have a 100 meg Ethernet connection, that means you'll have 100 megs out and 100 megs in. So effectively you'll have 200 megabits, 100 megabits in each direction of throughput. We'll take a look at the media rates and how that can come into play and what that exactly means. And then we'll take a look at duplex and speed options. So when it comes to half duplex, it's really important to understand this. This will be especially useful to understand when we start getting into spanning tree at the edge. And when we start getting into some of the specifics about how spanning tree is set up, you'll see that when you configure a rapid spanning tree, that you start getting specific with the port types, that things will start to change a little bit with the spanning tree outputs. So when it comes to half duplex, it's a unidirectional data flow. So typically this was a higher potential for collision, and it's a hub type of connectivity. So normally you would see half duplex communication in a hub environment because you couldn't send while things were being, or you couldn't receive while things were being sent. So look at it from this perspective. If you are on a hub and you have a frame commit on a port, you have to send to all the other ports on that hub to find out where that traffic is got to go, even if the receiving station doesn't need it or it's not destined for that receiving station. So you'll have to wait till the sending communication is over before you can receive an update. Now the drawback to that is when you're sending out every port, there's a higher level of potential for collisions to occur because there's no way to prevent that from happening. What you'll see also when it comes into spanning tree is you'll see that you'll see the shared style of port, and that is going to be typical to half duplex communication when that comes down to the edge type of interfaces. And we'll take a look at that in spanning tree in a much closer detail and explain exactly what that means and how it can affect the traffic. Now, with full duplex communication, you are dealing with point-to-point only. Now, this is attached to a dedicated switch port. It requires full duplex support on both ends. It is collision free and collision detect circuit disabled. So what this means for you and I is when you're dealing with full duplex communication, that is what switches are going to run at nowadays. So if you are, because of the fact that The only time you can run full duplex is when you have a dedicated collision domain. And remember how we talked about earlier, where every interface on a switch is its own dedicated collision domain. So with that being said, even um, today's modern networks and today's modern switching, you're going to be running in full duplex at the edge and at the uplink. Now, what do I mean by the edge? An edge port is going to be something that connects down to an end station, a computer, a PC, a server, a laptop, a printer, an access point, something like that. Where an uplink is going to be a connection from that computer up towards the switch. That'll be your uplink because it's going to be sending your uploading traffic. Where it could also be a connection from switch A to switch B. You know, that interconnection between the two switches is also referred to as an uplink from time to time. Now, with that being said, in order for this to work out, you can actually go in there and set the spanning tree port type to edge. You can set it to point, and if it does, you'll see how spanning tree will start to tweak itself as you go through, and you're basically what you're doing is you're optimizing spanning tree as you go along. But that's basically how the operations will work as we progress through here. Now with media rates, you have three different ones that are common in today's networks. You have fast Ethernet, which is 100 megabits per second. You have gigabit Ethernet, which is 1,000 megabits per second. And then you have 10 gigabit, which is 10,000 or 10 gigabits per second, or 10,000 megabits, essentially. So that is going to be one of the things that are going to be beneficial when you're moving forward throughout the rest of the series, is understanding how these come into play. Now, depending on the end station, and the switch will detect duplex and speed options automatically, and that's what they call, or actually brings us to our duplex and speed options category. Now, when it comes to setting the duplex options underneath the interface, you can set the duplex to auto, full, or half. Auto means it will automatically try to detect the duplex, or from the client side, it'll try to detect whatever the client is set to. By default, it's going to be auto, and that means it's going to be auto speed, auto duplex. Now, if it's auto speed, auto duplex, you're typically going to see on 100 megabit or fast Ethernet and Ethernet. Ethernet being 10 megabits per second, fast Ethernet being 100 megabits per second. The RFC for these guys, the 802.3 specification, states that fast Ethernet and Ethernet are going to be going to try to go half duplex. That is their default configuration. So it is possible where you will form a half duplex communication on a fast Ethernet link. That's what its default speed is going to negotiate to. Now, what will end up happening is the end station will typically have a gigabit capability, and if it can't, if the switch port on the switch can negotiate gigabit, but the interface of the computer cannot do that, then the switch port will downgrade its speed to match whatever the maximum throughput of the switch is on that port. It'll downgrade to that, and then it will try to negotiate full duplex so that you have bidirectional communication at all times. So that's going to be one of those things where you end up having to make sure you have it set up correctly. You can go in here and modify those things, and as you're progressing through here, you'll see exactly how that is done. Now, you also have to deal with the Metro Ethernet 3400 series ports. Now, the Metro Ethernet switch is typically going to be a device that's at the customer's location, and this is going to be the handoff from the provider. So the provider is going to manage that device and provide the connectivity to the rest of your network through it. Now, there are a couple different port types. You have the user network interface, or the UNI, or UNI. You have the network-to-network interface, or the NNI, and you have the ENI, or the enhanced network interface. So the way that this works typically is the UNI, or the user network interface, is going to be no switching of local traffic, which is just basically a dedicated connection between the provider's device and the customer's device. So what this means is host A on Uni port cannot see host B on another Uni port. Ports connected to end devices. So what this means to you and I is when you're going through and you're setting stuff up, UNI is going to be what you use to connect down to the customer. So UNI is going to do that, and it doesn't. It's basically the ports. If you're familiar with protected ports on a switch, two protected ports on the same switch cannot talk to each other. So if you have fast Ethernet 0/1 and fast Ethernet 0/2, if they're both set up as protected ports, they cannot talk to each other. It's not going to be allowed. Now, you could take this to the next level when it comes to protected ports and go to their big brother, which is commonly referred to as private VLANs. And that's slightly out of the scope for right now. We'll take a look at that in more detail later on. But that is a general idea of how this stuff will work. The NNI, or network to network interface, typically is going to, you're only going to have 4 ports that can be configured as NNI ports. Connects to the core network, and typically is going to connect to a router or to another switch. So this is going to be your connection to the core, it could be your connection to an edge device, something like that. Now the ENI, or Enhanced Network Interface, is going to do pretty much the same thing as a UniPort or a UNI. It has some additional support for protocols that aren't supported on user network interfaces. That's going to be CDP, spanning tree, and then your link aggregation control and your port aggregation control protocols. Now, an output, I don't have an ME3400 switch to show you, so the quickest, easiest way to do this is to show you a quick screen cap of something that you could see. And basically, as you can see here, you know that these 3 ports here are connected down to an edge device. Could be another router, or it could be the another device of some type that's a host, an IP phone, for instance. ENI is going to add additional capabilities, where you could be doing these 4 ports could be bundled together in a port channel, and then Gig 01 and Gig 02 are more than likely connected to an uplink beyond that. Now, configuring your ME3400 switch ports are actually pretty easy. You just go underneath the interface, and on the interface at the interface level, you would simply type in the port type, and then you have to specify the specifics beyond that. So once you've configured it, it's pretty straightforward and going from there.